Hello, I hope I'm visible. If somebody's watching, kindly comment, let me know. Uh, it's showing that it's working over here. Alright, so let's get started. I'll just pause the music. I don't want it playing. Alright, hi, hello. My name's Advait, and let's start with Python. What is Python? Python is just a high level interpreted programming language. It is known for its simplicity and readability. It was created by Guido van Rossum. Good man, intelligent man, and it was first released in 1991. So Python is designed to be pretty easy to write and understanding, and make it popular by choice of beginners, and yet it's quite powerful enough for experienced developers to build complex applications. So there are quite some features of Python. I'll just quickly switch to the tablet mode and I'll change my screen. Yep. So this is how we're going to do this. Going forward, we'll just stick with this. Here you can see what's written as well as you can see me. And yeah, let's get started. So there are some key features of Python. One, it's simple and readable, right? And I'll just scroll down a little. So Python syntax is pretty clean and straightforward, which makes it easy to learn and understand, especially for beginners. And next is interpreted language. So Python is an interpreted language. Interpreted language means it is processed line by line. The code is executed one line at a time, so it makes it really easier to debug in test programs. And it is available on cross platforms. So Python runs on various platforms like Windows, Mac OS, Linux, and more. And it allows developers to write code that is portable across different systems. Then next is dynamic typing. You don't need to declare the types of variable explicitly for Python. The type is determined at runtime. So uh, the thing is, when you're writing code in C, C++, or Java, before writing the type of variable, you need to define whether it is an integer or a decimal or like that, or a string. But in Python, you can simply go ahead. It has versatile use case, so it is used in web development, data science, machine learning, and whatnot. Even automation and scripting, everything is done mostly in Python these days. And the best part is it's community support. So community support is actively seeked when you're developing, right? Especially if you're a beginner, you will get stuck in numerous points and then you need to search it in the web. Then you need a big community for that. So Python is good choice to start with. So let's look at the possible career path that you can have when you're a Python consumer. So basically, what I mean to say is that these following career path that I'll discuss right now is very crucial to their particular industry and they require Python. So let's start with software developer. Now, software developer, they are just normal developers who use uh, Python for developing software applications, tools, and the skills that they have is object oriented programming and web development. They use Django or Flask, and they use REST API, software testing, and version control and whatnot. The industries they are mostly into is tech industries, tech companies, startups, enterprise software, and whatnot. Next is data science. So data science is what I do. I'm a data scientist myself, and our role is to analyze and interpret complex data to help organizations make data-driven decisions. Okay, so the skills that we acquire is data analysis, statistics, machine learning, and we do it with the help of libraries that were built in C, but they are used in Python. So like pandas, numpy, scikit-learn, all these. And the other skills that we also have is data visualization and big data tools. The industries which we mostly work in is finance, healthcare, retail, tech, e-commerce, consulting, etc. So next is machine learning engineer. So machine learning engineer is a person who builds and deploys machine learning models into automated tasks, and they make predictions and create intelligent applications. And they heavily depend on Python for this. They use libraries like TensorFlow, Keras, PyTorch, and whatnot. Then comes the role of web developer. Okay, so web developer are somewhat like software developers, but they just work on the web. They build dynamic, scalable, and secure websites for web applications using Python based frameworks. They also use different languages, but Python is not a popular choice for web development as such, but it is reliable and it can be used to do so. And there are some industries, some companies which use Python for these specific tasks. So they work on the front end, back end, using again Django and Flask APIs, a database, and whatnot. DevOps engineer, okay. So, DevOps engineer uses Python to automate processes and manage infrastructure. The major task is to improve stability and reliability of system, and they make sure it is very well done for the development environment. The skills that they acquire, or I should say require to start with, is Python again, to automate scripts and configuration and continuous integration. We call this CI/CD. And cloud platforms like AWS and Azure, they are a lot set up by Python itself. Next is data analyst. Data analyst is somewhat close to data scientist because they also collect and process and perform statistical analysis on data sets to extract insights for business decision making. The skills that they have is Python for data manipulation, and data visualization can be done using again Python, or they can use other BI tools like Tableau or Power BI. I personally use Amazon's QuickSight. QuickSight is a very powerful tool since it's integrated within Amazon itself. Mostly they work in industries like finance, marketing, healthcare, government, consulting. And there are others like cybersecurity analyst and automation engineer, artificial engineer, and artificial intelligence researchers, and quantitative analysis. So quantitative analyst, what they do is, I'll tell you a little about that. They use Python to analyze financial markets, especially the people who interact with trading a lot. Again, Python is used over here also. Game development, test automation engineer, bioinformatics specialists, and cloud architecture, and blockchain developers. These all again used Python itself. So, if anybody wants to ask anything specific about any of these roles who are interested, kindly let me know in the chat. If you want, we can talk about it in more detail, or otherwise, we'll just move ahead with installation. right. So I guess we should move ahead with installation. Okay, so I'll just quickly switch my screen, and I'll show you guys how to do it. I hope I'm visible. Yeah, the screen should be visible now. Now, what we have to do is we go to python dot org. I missed a T over here. Python.org. So either you can come over here or you can simply search download Python. You can do a Google search as well. Okay, so you're here. Once you land on this website, you're supposed to hover over downloads, and then you'll come over here. So it's Python 3.12 as of today, but maybe later down the line, if somebody else is watching later on, the version might change, so you need not worry about it. Just click on it and then the download will start. The download has started. I had already done it before itself, so I don't think there is a need to do it for me again. Yet it is downloaded, it's okay, never mind. I'll just click on it and then you will see the startup. So this installation, I hope everybody has, people who are watching, they have their laptops or computers ready. I was thinking if you guys would like to follow along this installation procedure, or maybe you could just look at it right now and do it on your own later on. So if you're following right now, you can simply comment if you want something, or if you're stuck anywhere, we can discuss it right now. Before going ahead, make sure to click this. This will save you a lot of hassle and time, because then you'll have to go to the environment variables and do a lot of nasty things. And next, if you're using your own system, I don't think if you click on this will have any issue. It will just ask you in a dialog box that should you go ahead and do it like this. So just click yes and it will start installing. I hope I'm audible. Yeah. The meter is working fine. Okay, the setup was successful. You can simply close it, you don't need this. Now that you have this installed, you can simply start away and write your first Python code. You go to all apps, you scroll down a bit until you see Python. Yeah, here it is. So these are the things which have been downloaded, and out of these two, the most important is ideally in Python 3.12. So Python is basically you can say this is basically a software. Also, you can call it a virtual machine box, and it runs your code. It transforms your code into something that the computer can understand, and Yeah, that pretty much that's it. If you click on this, ideally it is the development environment. So by default it is a shell. Shell is something, you can think of it as an interpreter that takes line by line input and then outputs whatever you want to write, if there is an output. So what I'll do is I click on new file. When I click on new file, you will open up a sort of notepad. This notepad can be used to write your codes. So we'll just write our first code. That's it. We will do this print hello guys. So what print does is it gets an input. This is an input, and then it takes it and stores it in the memory, and then it prints it. Prints it in the sense it will give this as an output, whatever is the input. We'll run it. For running it, we'll have to save it. I'll just go to Python for idiots basic intro. I'll call this first file.py, replace it, and see, here it is. Hello guys. So whatever I write over here, hello 1 2 3 4, and run it, it will start printing that. If somebody is following along, I hope you've reached till this point. Or if you have any doubt up till this point, you can ask in the chat. Alright, you guys write your questions whenever you want to. I'll go ahead. And what I'll do is, I'll make this a little tricky. I'll create a new file again. And I want to show you how the Python process works actually. And for this, I might want to create something like this. Just give me a second. It's funny. Never mind. I'll just go ahead and do it over here itself. Okay. So basically, I just created a function, and this function will just print whatever it is. Let's not get into details of what uh, did I do over here. Let's try to understand what's happening over here. So, how does Python works? Let me just quickly change my. Okay, let's get into the working of it. So, as you can see, I created the stem.py file, also this file, and what happened is I created a function inside temp. Something I created something inside temp, and it had to be stored inside Python's memory so that I can use it later on. So what happens is when I try to run any Python file, it will go inside an interpreter. Now, what is an interpreter? Interpreter is the software, basically, you can say, that runs the code and then give you the result. Now that we know what interpreter does, let's just jump into how compiler works and uh, what is inside basically the interpreter. So there's just two parts: Python's compiler and then Python virtual machine. So what happens is this python.py file is sent to compiler. Compiler turns it into bytecode. Now just make sure that you do not confuse it with system code. This is not system code. You cannot give it to the CPU directly. It is bytecode, and then it is sent into Python virtual machine. This Python virtual machine is basically the software that runs your code and then gives you the result, right? So if somebody asks you that whether Python is an interpreted language or a compiled language, you'll say it is an interpreted language, but it does use a compiler. But it is not that same compiler. It has a different structure. Its base job is to just convert this basic English looking like code into a bytecode. That's it. Now this is the bytecode. It's stored in the pyc file .pyc. It will convert your .py file into pyc file. You can here see the file name is temp.cpython dash 312.pyc. So here temp is the file that I made, temp.py, and then .cpython. Cpython is the type of Python that we usually use. 90% of the cases you will just see cpython. There are other types of Pythons like jpython, pypy, and many more are there. Let's not get into that. And 312 is nothing but 3.12 that we saw earlier during the download. Here 3.12, 3.12.6, but it just takes the first two or three. And pyc. Now let's see if we what happens if we try to open it in notepad. I don't see anything right. Oh, here it is. So you'll see something bizarre like this. Basically, the notepad isn't able to read this. That's it. Now, coming back to the code. And then this pyc file is sent to the virtual machine, and then the result is displayed. Now, I'm pretty sure that all this seems a little bit intimidating, but it is very easy. Trust me. Now I'll go into this screen and I'll try to explain you in detail what actually happens. Now, if you feel like this is where you want to leave, and this is pretty much enough to get started. Honestly, next what we are talking about is tad bit complicated, and it is only for the enthusiast. If you really want to understand how Python works within, and you're not here to just understand the basics and want to learn learn more about it, and you want to get the details on the running, please feel free to continue. Otherwise, at this point I think I've cleared how to download and install everything, and here you can simply write your Python code. You can look up the web, and maybe in the next class I'll teach you how to start writing the code, and this is it. This is pretty much it. Now go to this particular path. Yeah, here it is. So I'll quickly come over here. I'll tell you about what's actually happening over here. So first of all, we write the code. Okay, remember we wrote print and then hello guys, right? So that is us writing the code, and we will store that file in the script.py, and we write this in any environment. It could be ideally, it could be, or anything that I will later show you guys how to use different environments. But the thing is, where do you write the code? So it can be notepad, anywhere. Then comes a lexical analysis. So lexical analysis is, you run the Python script and then it breaks it into very small parts. These small parts are called tokens. Okay, so in print, I'll just simply write it and show you. So if you write print hello world, so here print is a keyword, and this is a delimiter, this is a string line, this again is a delimiter, and these will be breaking into these particular parts. Okay, now the next step is syntax parsing. Okay, the syntax parsing is after tokenization. The Python goes through the process of parsing. This step checks if the code is following the Python's grammar rules. So every language has its own set of grammar rules. Grammar rules is basically, it will define how things are supposed to happen, in what context it is supposed to happen, and what should be the following procedure to read this code. All right, so that a machine is able to understand what you are trying to write in English. These tokens are arranged into a syntax tree, and which is a structured representation of the source code. Okay, and if there is a syntax error, let's say there is a parenthesis missing, or you've given wrong number of spaces, the interpreter stops there itself, and then it throws an error at this stage that, see here, this is where you're doing something wrong, and it is not supposed to be happening. All right, and these are sometimes wrong codes or whatever it can be. The next step is intermediate code generation. Okay, so abstract syntax tree. This syntax tree is generated only if the syntactically correct code is passed on. So congratulations, if you did not catch any syntax error, then Python generates this abstract syntax tree. So this tree is like a representation of structures of the code, and it provides more abstract representation of the original source code that is that the interpreter can work with. Okay, so example, the Python hello world, it might be represented as a node in AST with two child, and one of them is the print function and one of them is the hello world. So it will be somewhat like this. This is hello world, and this is print. That's it. The computer tries to understand it in this way. Next comes is the bytecode compilation. After creating that AST, the abstract syntax tree, the Python translates that particular code into bytecode. Now, bytecode is an intermediate low-level representation of that code. Remember, I showed you that PYC file. This is that bytecode. This is that file where that bytecode is stored, and it will be always stored in the extension like this, underscore underscore py cache underscore underscore. So it's like underscore underscore. I know it sounds very weird, but throughout your journey in Python, you will always find this underscore underscore, starting with double underscores and ending with double underscores. All right, and yep. Next is execution by Python virtual machine. So, as I told you earlier, the Python virtual machine is the software which you had just downloaded, and it is the software which runs the code that you've given it, and it is the runtime engine of Python. Okay, so no matter what your wrapper is like where you're typing the code and who's running it, doesn't matter. The engine is Python. That PVM is the engine of Python. So you can sit in a car made out of wood, made out of steel. As long it's having the same engine, it will work the same way, right? So once PVM is receiving this code, after receiving this code, the PVM will run and it will execute that bytecode instruction. The PVM interprets bytecode line by line, and it performs the actual instructions like printing to the screen, performing any arithmetic interaction with files, or whatever it is, whatever instructions you've given it. And at this stage, the Python code is executed and you get to see the output or the results. Okay, and after that, when you see the output, a garbage collection and memory management process comes. Okay, so in garbage collection and memory management, the Python has a garbage collector that manages its memory. Memory is RAM basically, and it deallocates memory that is no longer in use. So let's say you consume some 20 kilobytes of memory for some process, and after that process is run, you cannot just keep that 20 kilobytes of memory to yourself. You need to give it back to the operating system, right? So this is what garbage collector does. And next is error handling. Of course, there's error handling. So during execution, there are some errors that you might face, and this is how it happens. That error handler, it just gives you that error, like whatever happened. Let's say you wanted to read a file, but the file was already open somewhere else, and it is not allowing it to read it to you. So it will show something like this file is open already somewhere else. Kindly close it before trying to open it in Python. It's a fair case. So in such cases, what Python gives you is very good error handling features. It gives you 3 blocks. I'll just write it out for you. Try, accept, and the next is finally. It helps you to continue your code. Your code doesn't stop in between. So if you try to read a file and if it throws this error, so what it will do is it will if you say try and then accept whatever error it is, it will just carry on. It will say the file was not read, no problem, we'll continue with whatever the next instruction is, will not get stuck over here. And of course, then the exit is basically you leaving the whole shell, the pvm is closed, and then you come out of it. So this is how Python works, and now you know what's going inside the whole black box. Now I'll show you something very nice. You come back to this particular screen. Just give me a second. Okay, let's come back to the screen. Here, what you've got to do is you have to go to Google and you'll say, I want to download Anaconda. It will show you results like these, and you want to click over here, download Anaconda distribution. The link should be anaconda.com/download. Here, when you put your email address and click on submit, you will be taken to the next page. So I'll just show you. Now that you're over here, if you're using Windows, please use this. If you're in Mac, do one of these. So once you click over here, it will start downloading this. I don't want this. I'll just cancel it because I already have this already downloaded before the stream started. I'll show you how to install this. Make sure you follow this, otherwise you might face some problems later down the line. So it will be somewhat like this. Click on it, you press next, you scroll down, you try to read it, but then you just click on agree and move on. I'm downloading this for just particular this user. If you want to download it for all users, it will require admin privilege. So if you're doing this in your office laptop, you might not have this, or you might want to connect with your IT team to help to get help with this. You click on just me, and this is where by default it will be stored. Let it be. It's not empty. We'll just give it another now make sure when you're coming to this particular page, you add Anaconda 3 to my path. This environment path is supposed to be added, otherwise you'll have issues making Python and Anaconda work together in different parts of the system. You can register Anaconda 3 to your Python default Python program, so later if you want to run any .py file, Anaconda will run it instead of the Python. And then clear package or whatever you want to do it, it's your wish. When you click on install, you can click on show details and this whole thing will get installed. Since it's a big package, it usually takes its time. Meanwhile, I hope you guys are still there, and if there is any doubt up till this point, if there is any place you think you're stuck, you can definitely ask me. almost done. Yeah, it does that. Yeah. Takes all the history, clears the package, cache, and everything. And then it should get installed. Yep, it's done. Next, you click on finish. You don't want to click on this, and let's click on launch Anaconda Navigator. Now, Anaconda is a very powerful tool. It gives you a set of different tools which has Python integrated into it. I personally love to work with Spider and Jupyter Notebook, and I'll show you how it works. It's quite fascinating, and I hope you guys use that. It will help you in debugging your codes and looking at all your variables, especially when you're doing your analysis. You sometimes want to look at your variables, and it's good to have them listed down in one particular layer itself. You don't want to keep typing your variables one by one. So first time when it's loading, it will take a little bit of time, and once that is done, it will be available. Is it opening? I hope it is. But where is it running? It says it's running, but huh? I don't see it. Well, let's task manager. Open up task manager. I'll see Anaconda. Is there any Anaconda? I don't see. Can you guys see it? Oh, here it is. That's probably because I ran Python before. Make sure you restart your system. I cannot because all my live streaming softwares are running, but make sure you do restart before running Anaconda. Okay, here it is. So when you open up Anaconda, you might feel a tad bit intimidated by all these whatever it is here. Trust me, you just want to use launch. You just want to use Spider and Jupyter Lab. You can click on launch. I'll show you Spider first, and then we'll go to Jupyter Lab. Here it is. So this is where you write your code, this particular area, and this is where it stores all the important variables. So what I'll just quickly write some variables down. X equals 23, y equals to 2234, and let's say z equals to a string. Is an array of numbers. Oh, sorry, strings. Okay, that's string. Now, if I run this, and I'll just simply print y, c, okay. So here you can see it shows you the output. Here it will show all the variables that have been stored. So if you press on it, it will show you in much detail. It is pretty good when you're looking into large data frames. But for now, let's just look into this like that. And x, y, z, all the variables are stored over here, and different types of variables, like this is integer, this is integer. Let me create a dot over here, dot 23. Now you can see it's a float, and the output has changed. And this is how it is. Numbers are orange, strings are green, list and other types of classes are bluish tint. So whatever it is, you will be able to get it done over here. It's quite powerful. I love it. And I'll show you Jupyter Lab as well. This is how Jupyter Lab is like. So it's basically multiple cells, and you run each cell one by one. So let's say you want to run this code. Basically it's the toolbox over here. Here you get to see all the folders, and these are basically the terminal section. You can see all the kernels and terminals, so that's running over here. And this is basically table of contents and extension manager. So if you want to download any extension, you can do it from here. But initially you just need to work over here. So whatever you write, x is equals to 1 2 3 4, whatever it is, you can press on run and it will run it. Now if you want to print x, it will print. Now in next session I'll be continuing to use Spider, because it is good for analysis. So whatever we will do, it will be able to reflect in the environment variable page, my bad, in the variables page. And also I will teach you how to approach a solution using graphs. And once charting is done, and once basic code is done, we will start coding normal simple questions in Python. I hope everything today that we did was clear. Python is not that difficult. It may seem a bit intimidating in the beginning, but it's quite easy, and I hope you guys have fun with this. And there's a big industry in Python, and I don't see any other language replacing it very soon. So yeah, you're good to go with it. Alright guys, I hope you had fun. I hope you learned something, and I'll see you in the next one. Bye.